Welcome everyone. I'd like to give a brief introduction of what's going on for the next spin up for the Stubby Fan V2 motor. It's a turbine, yes, I know. People don't like it when I call it a motor, but here we go. So we have our MAD 8318 engine that we're going to be using at 100 kV. We are experimenting with a 48:1 gear ratio planetary gearbox that I've adapted with cutaway parts so that if there's any binding in the box, if anything happens, it breaks off or the gearbox fails and binds up. I don't do any damage to the rest of the system. I'm printing the fan now. This one is clear PETG. We are running it at 100% infill, concentric, and top and bottom layers, all concentric. And the reason for that is even the weight distribution out of on the fan, so that we can have an accurate spin up. Hopefully with the extrusion, there doesn't have to be a lot of balancing done with the fan as long as everything's concentric. We are running it off of 150 amp Fly Color Fly Dragon ESC, external BEC, because this is 48 volts. Didn't come with a BAC or BEC, so we went ahead and picked this up for that. The batteries 270C 22.2 volt run in series, obviously. The first test is going to be very low RPM spin up because we have a theoretical 15% throttle fan speed of 78,000 RPMs. Now, with the 800 kV motor, I was pushing about 12 to 15,000 tops, but that was with the Stubby Fan V1, which is down here. A legend in his own right. But the twins will be next eventually. I got caught up in this whole situation. So I kept running into an issue with kilovolts versus mass of the blade versus ESC and what voltage I was using to push the system. So I went with like I said, this MAD 8318, 48 volt setup, 150 amp ESC, which is way above what this is called for, but it will actually give us some headroom, which is nice. So if there's any or a lot of drag from the blades, considering it's a 22 blade high pass configuration, it will absorb that heat a lot better. Also, it's fairly cool in the garage, so being this time of year, so that will also help. Our idea behind this test is for integrity of the blade. What RPMs are the safe RPMs, so we can set up a limiter on the ESC in order to make sure we don't destroy the fan. We want to find out the theoretical maximum RPM of the fan with its design. That will give us an idea of what we're dealing with as far as RPMs. Now, the thrust will be measured on this system. It'll be measured sort of a rudimentary way. It's just using a scale at this point. The load sensor setup will come after I'm able to get the 220 kilogram load sensor. It's an HX7 style. And I'll run on Arduino and basically record the data, and then we'll see the exact amount of thrust. Now, the scale goes up to 110. If we max it out, then we know we're on the right track, depending on what RPMs. Because this is a high gear ratio, but I can't always knock it down. So instead of 48:1, I can pull out one of the sets, put in the extended shaft, and run basically 16:1, which is still in the 78 to 80,000 RPM range. But we're gonna find out. The idea is to see what percentage we get to get a specific pounds of thrust. If we max the scale out, great. Now, I'm not gonna be filming from inside this room. I'll have cameras in here set up. I'll have a microphone in here set up so I can get some good audio on it. I'll have the NT1. I'll be monitoring from a camera mounted here at my computer on the inside of the house, behind this firewall and the fire door. I'm taking as many safety precautions as I possibly can because I want to make sure that I don't catch one of these blades in my forehead. Okay, so we have to be really careful. I do not suggest that anyone attempt this unless you are very well versed in how EDFs work and RPMs and flying metal and plastic at extremely high velocities. Please do not attempt this. I'm not encouraging anyone to attempt it. I am basically doing a research study on this engine design. We did really good with Stubby Fan V1. V2 is a whole new beast. So with that said, I am printing the fan now. We're going to be doing 2 fans. One will be PETG clear. The other one will be PETG CF. All 100% infill and concentric. We're going to see what RPMs give us what thrust. When the fan fails, I have to fail the fan. If I don't fail the fan, then the test is pretty much worthless. I need a safe operating RPM. So that's what we're going for. And we are going to measure RPMs based on the gear ratio and the throttle position and the output of the motor. So that will give us our RPMs at the fan without directly measuring them. After that, we will basically set a governor on this to where once you get to full throttle, you are at the theoretical maximum of this with a safety margin, of course. Then we will find out exactly how much thrust we've got. We'll do the load sensor test. Even for this test, we'll have all the ductwork on the system. Later on, since the core of this is an impeller, this system will feed an afterburner we're going to put together. It'll be about 150 millimeter, 200 millimeter tube. It'll have a propane burner that sets, sprays in the fuel and an igniter, and it'll be using the impeller pressure from here to actually operate it. Now the idea is, since the burn will happen a little bit farther away from this, that it won't transfer heat back to the system. The high pass fan will cool everything off as it's coming through. So we're gonna see if this part survives being in contact with its afterburner section, and if the high pass fan is enough to keep it cool and keep it operating like it's supposed to. So that's another milestone we're looking for. Now, after this is done, since I was basically looking for a high torque motor, I'm going to pick up another one of these and another one of these. And that is what we will run on Twins. Everybody remembers the Twins. It needed a high torque motor. It's a 2-to-1, but if we run a gear ratio at like 4 or 8-to-1 or even 16-to-1, and you double that, 32. Maybe we'll do 8-to-1. We'll do 8-to-1, and then we'll set it up on the center gear here. We'll use the same motor, same setup, and we'll get the Twins going. They're still going. I gotta put another motor in Stubby because we ate up the magnets on that thing. The other Predator engine that I was going to get that still runs on 6S is gonna go on that engine there. That engine is for another project. It'll still produce enough thrust for what I need it for. It is for the Cuddy Black when I build it. Everybody knows the Cuddy Black from Star Citizen. It's like literally the only ship that everyone loves, because the rest of the game, unfortunately, doesn't work that well. So we got a Cuddy Black, we're just gonna go hang out. You know, you all know what I'm talking about, right? Everyone who plays Star Citizen, you know exactly what I'm talking about. Okay, I made the mistake of getting an Eclipse. I don't know what's gonna happen with it. But anyway, we are just about ready. I'm printing parts as we speak, and we will be ready for a spin up fairly soon. So I hope you will join us for that. Please like, share, comment, subscribe, give me your ideas, tell me what you think. What do you think is going to happen when I spin this up? I know everyone, like 90% of you, it's going to blow up. I mean, I get it, okay? That's what this is all for. We saw the success we had with that one. This is the next iteration. So I hope everyone's ready for it. I hope you all enjoy the content. I appreciate you stopping by to watch the video. And if you like what you see, let me know. Like it and share. Subscribe. Be a turbo head. Join us. All right, until next